It is day 26, everybody. Day 26 of 31 total days in this term. That's exciting. That's very exciting. We are almost done with Algebra 1. Kind of crazy. And it is Wednesday today. February, what's the date? Yesterday was the 26th. Is today the 26th? Okay. It is. Forgot I changed my calendar last night. Okay. So today for your do now, I had you guys work on your exit tickets from the last 2 days. If they were not completed yet, and maybe make corrections. Very good. And then I gave you a few problems to work on if you finish that. So whether you have began on these or not, we're going to look at them together. So if you have, go ahead and get that work out. If you have not, I'll give you guys a minute to copy these down, just in case you were working on the exit tickets. So I'll actually pause this recording for about a minute and let y'all do that if you have not yet. Okay. So let's go ahead and look at number 1. I'm asking you to simplify all of these expressions, whether it is with multiplication or division. For number 1, we got 3x to the 4th power divided by x to the 3rd power. Who would like to tell me what I should do to simplify this?
Okay, so since it is division,
Mm-hmm.
in my brain, the first thing I'm going to do is subtract 3 from 4.
Yes. Okay, so since it's division, you decided we will subtract. That is correct. And you said we're going to do 4 minus 3?
Yeah,
Perfect.
which leaves me with just the 1x, so
Mm-hmm.
that leaves me with 3x.
Perfect. Okay, so our answer here would be 3x. And I'm going to write some work out just to show it. If we wanted to think of it in terms of the subtraction method, we know that division turns into subtraction when it comes to exponents. It would be like 3x to the 4th power minus the 3rd power, or 3x to the 4 minus 3. And 4 minus 3 is 1. So we get 3x, no exponent needed. We could also think of it this way. If I know that I've got a 3 as my coefficient, I don't really need to worry about my 3. If I just wanted to look at x's, I could think I've got 4 on top. 1, 2, 3, 4. I've got 3 on bottom. 1, 2, 3. So with subtraction, or not subtraction, with division, we're canceling terms out as we go. So I could cancel my x's out for every pair I have amongst the top and the bottom. Here's 1 pair I can cross off, 2 pairs, 3 pairs, and I'm left with 1x. So that's why we'll have 1x in our answer, and a final answer of 3x. Okay. Does any part of this explanation not make sense to anybody? Is anyone confused about where the 3 or the x came from? We feel okay about it? That is good. Okay. All right, let's look at number 2 then. Now I have a different kind of problem. 4x, and then in parentheses, x squared plus 2. Is this multiplication or division? Multiplication. Good. How would I solve this?
4 times x.
4
times 1. And then 4 times 2.
Oh, yes. So we're looking at our coefficients first, and you're distributing 4 times 1. I know my first term is going to be a 4, and we're ignoring the x's at first. And then 4 times 2.
8.
8. So I'm just going to write those. And then we want to look at our x's.
Invisible 1 to 2.
So this is x1 times x2, which gives us x3. Good. And I'll put my plus down.
And you know, there's already just an x behind 8 because.
Yeah. So now we just have x times the 2. Well, I guess not the 2. We already did 4 times 2, but there's an x attached, so we just attach that x onto our answer as well. So we should get 4x to the third power plus 8x.
And to double check, you can do what you do normally. Make sure it goes in.
Yeah, we could kind of reverse, we could factor it and see, well, if I divide both of these terms by 4x, will I get x squared plus 2? Does anybody want to see that process of how we can check this answer? I can show it just in case. Let me get a little sticky note out, so it's optional. So if I want to check my answer, I can work in reverse. I see that I have 4x to the third power. So our simplified form, we have 4x to the third power plus 8x. That's the answer we just got. And how would we check our answer? How do we make sure this is correct?
Factor.
We're going to find factors. We're going to make sure that we can put 4x, like in the original problem, under both of these terms and make sure that we should be getting x squared plus 2 inside that parentheses. So let's see. 4x here and outside. So what happens with my first term? 4x to the third divided by 4x.
1. 4 divided by 4 is 1.
Yes, my 4's cancel, so I'm left with 1x to the something.
3 minus 1 is 2.
Good. I have 3 up top for x. I have 1 on bottom for x. 3 minus 1 is 2. So I will have x squared, which, looking at our original problem, so far so good. Now let's look at our second term. I have 8x over 4x. What's 8? Go ahead.
8 divided by 4 is 2.
Perfect.
And x cancel out.
Yes, my x's cancel. 8 divided by 4 is 2. And look at that, it matches. So this is the correct answer. We did it right. Awesome. All right. So there is number 2. And I'll keep that sticky note up there for a moment. And let's look at number 3 now. Is this a multiplication problem or a division problem? Multiplication. Good. So I need to take x squared times each of my terms. So what is x squared times 5x?
5.
Mm-hmm.
X to the third power.
Good. 5x to the third power. We just brought the 5 down, and I know x2 times x, this is a 1, gives us 2 plus 1 is 3. Okay, so we've got 5x to the third for my first term. I'll bring down my plus sign. Now I have 2 and x to the second power.
2x squared.
2x squared. 2x to the second power. That is our answer. Good. Any questions on number 3? We go to number 4. This one's a little tricky. This time I put two variables in here. We haven't really looked at one like this, but we're looking at it now. So first off, what's going on in this problem? Are we multiplying or dividing?
Dividing.
We're dividing, okay? So I know am I going to be adding or subtracting my exponents? Yes, we're going to subtract the exponents. So
7 divided by 1. The x is a 1, imaginary 1.
yes, there's an imaginary 1 in front of this x squared. So you said 7 divided by 1, and what will that give us?
7.
7.
To the square. X squared.
Ah, yes. How did you get x squared?
Subtracted.
We subtracted. 4 minus 2 is 2. And how about y?
And we're going to do y divided by y, which is y. 1, 1.
We have y to the third power up top,
Right.
and y to the first power on bottom. So what are we subtracting?
Y from the y's first.
Yes. What number of the y am I subtracting here?
3
Uh-huh.
and the 1.
3 and 1. So what is 3 minus 1? 2. So I have y.
Yeah.
The second power. And that should be my answer. Now I'm going to write this one out with our x's and y's over each other to cancel, because sometimes that visual helps. So I'm going to use different colors to show that. So my original problem is 7 x to the fourth, y to the third. So I'm going to rewrite that as 7 fourth y. Second y to the first power. If we're looking at all the x's first, I've got 4 x's on top, so I'll do that. 1, 2, 3, 4. I've got 2 on bottom. 1, 2. And then my y's. I've got 3 y's on top. 1, 2, 3. I've got 1 y on bottom. 1. So this is where we could cancel them visually without thinking of them as subtraction. I could say, well, I have 1 pair of x's, 1 on top, 1 on bottom. I'll cross that off. I've got another pair of x's, 1 on top, 1 on bottom. I cross it off. And how many x's do I have left?
2.
2. And look at that. That's where we got our 2 from on the x in our answer. And the y's just have 1 pair we can cross off, leaving us with how many y's?
2.
2. And look, that's where it came from. We got x to the second power and y to the second power. And our 7 does not change. So that is our answer. So even though there was an extra variable added in there, did that make it too much harder? Not too bad. Not too bad. We're just doing one extra little step there. That's good. Okay, guys. That is all I'm due now, today. Does anyone need to see any of these notes before I move this paper? Okay, I'm going to go ahead and move then. Some notes. So today we are going to introduce something slightly different, but pretty similar to what we've been working on. We've been doing a lot of multiplication and division amongst our exponents, our coefficients, all of these things. I'm going to add one more little thing in along with this. Let's see. I'm going to talk about what would happen. Yeah. I'm going to think about what would happen if I had a problem like x plus 1 in parentheses times 2x plus 3. Something like this. Now, whenever I have two things in parentheses besides each other, what operation is happening here?
Gotta take care of what's in parentheses.
Yes, normally we would do what's in parentheses first. However, since we don't know what x is, there's not a lot we can do in that parentheses.
So would we add our x's together? Like, since there's an invisible one there, would it be like 3x?
If we were adding, yes, but this is not addition technically. Multiplication. Yes, so what's happening here is a big multiplication problem. What we are used to seeing is something more like this. We have just one term being multiplied to something that has two terms. Now I have two terms multiplied by two terms. There's a few more moving pieces here. So I'm going to teach you a method today, two different methods, that's going to make this a little bit easier than it might look. So I'm going to write here at the top of my page, FOIL, FOIL method. Here's what FOIL means. F means first. O means outer. I means inner. And L means last. So I'll let you guys copy that down, and then I'll explain a little more what those words mean, how they're going to help us. First, outer, inner, last. And I think some colors might be helpful. Let me see. Different from each other. Okay, so first means we are looking at the first term in each set of parentheses. So when I'm referring to the first term, I mean x and 2x. These are the first terms. So the first thing we're going to do is draw a line from the x to the 2x. And what we're doing there first is x times 2x. Now, what is x times 2x?
What?
2x. What
2x
happens?
squared.
Yes, 2x squared. And does everybody see how we got 2x squared? Or would anybody like an explanation for that? Can anybody tell me why it's 2x squared?
Because it's 2 x's.
Say it again.
2 x's.
2 x's. I have an x here multiplied by another x here. X, x. There's 2 of them now. So it's squared. There's 2 of them. So we did our first term. Now we're going to do our outer terms. The outer terms is that first term and that last term. They're on the outside boundaries of the problem. So it's x times 3. It's a little tricky to see. I have a different color. Three. What's x times 3?
3.
3x. So I'll list that out. 3x. Okay. So we've done the first terms, we've done the outer terms. Now we're doing the inner terms. The inner terms are the ones inside here, the 1 and the 2x. So I'll draw and connecting those. And I'm multiplying them. 1 times 2x. And what does 1 times 2x give me?
2x.
2x. 1 times anything is whatever that is. It doesn't change it. So we have 2x now. And now we do the last terms, which in the first set of parentheses, the last term is 1, and the second set, the last term is 3. So we'll draw a nice little line going from 1 to 3, the last term. We're doing 1 times 3. Now what is 1 times 3? 3. So now we have a list of 4 different terms here. 2x squared, 3x, 2x, and 3. Now, whenever we use the FOIL method in the future to multiply different terms and different expressions like this, it'll go a little bit quicker as we're not necessarily listing out all of the multiplication problems and all of that. But since this is our first example, I did want to go through it slowly. And what we're going to do is we're going to take all of these answers we came up with and we're going to write them out side by side with plus signs in between. Because what's happening here is we're doing a lot like what happened here. We're multiplying x squared times 5x. We got 5x to the third power. There was a plus. X squared times 2 is 2x squared. In this problem, we're doing the same thing, bless you, where we're putting plus signs in between everything. So I did x times 2x, and I got 2x squared plus, then I did my outer terms, x times 3, to get 3x. And I did my inner terms. 1 times 2x, which gives me 2x. And last but not least, I did my last terms. 1 times 3, and I got 3. So, with 4 different steps to multiply these 2 sets of terms, we end up with 4 new terms in our answer. But we're not done yet. There's one last step to a method like this. So,
You put it together.
ooh, put it together. Put what together?
Combining like terms.
Yes. Combine. You guys are so smart. Okay, what like terms do I have that I need to combine?
3x plus 3.
3x and not the 3. There's no x on 3.
2x.
2x. We're looking for any terms that have the same variable and the same exponent. These are both x to the first power. So I can combine them. How do I combine them?
I'm add.
I'm going to do the operation written in between, which is a plus sign. So 3x plus 2x, which is what?
5x.
5x. Good. So that's our middle term, and we just bring everything else down. 2x squared plus 5x plus 3. And that would be our answer. This is where we're getting into Algebra 2 stuff, guys. Y'all are doing really good with this. That's crazy. Is that scary?
Yes.
A little bit? A little bit scary?
Still confused.
I hear yes and no. Guess what? This is the first thing I've shown you. So if you're feeling great about it already, that's amazing. If you're not, don't even worry. This is the first one we've done. Let's do a bunch more together. And we're going to keep practicing this FOIL method. So that would be our answer for this one. And I'm going to give you another example. What if I gave you Can I throw minuses in? Or do we want to stay with plus signs for the first few examples? Please plus signs for a minute. Oh, I love you, Lisa. Okay, x plus 2, x plus 3. Let's do a simple one.
Okay, oh no.
Yes.
If you know what, that is so valid and it can be very overwhelming because this compared to what we started with looks crazy. This is not easy stuff at all. I mean, whenever I taught Algebra 1 first term, we didn't even touch this stuff. You guys, this is so good that we're getting this. Okay, so, by the way, I guess I'll keep this up in case anyone needs it. So in the FOIL method, we start with our first terms, then our outer and inner, and then our last terms, and we are multiplying. So, let's see. What are my first terms in this new problem? X and X. So, first is X times X, and I'm going to write it out, but this step that I'm writing below, it's okay if you don't write it. Sometimes writing the steps for this process can start to make it feel really painstaking. And you'll get to a point where you can do quite a bit of it in your head. But if it helps you to write it out, then absolutely do it. So, x times x, what is that going to give us? X squared. Because there's an invisible 1 and an invisible 1. So, x times x, 1 plus 1, 2, x squared. Okay, so that was our first term. What are my outer terms? 2 and 3, 3 and 2. These are going to be my last terms because they're the last on both. So outer is the first and the last together. X and 3. Good. And I'm actually going to do that on top here, just to not make it look so crowded. So my outer terms are x and 3. So I'm doing x times 3. And what is x times 3? 3x. And if you notice, guys, what's really happening here, just realize this might be a helpful way to think of it. I'm starting with x, my first term, and I'm distributing it first. I'm doing x times x, x times 3. Just like before where we would do our arrows, our 2 arrows like this. I've just separated the arrows. I suppose it would make more sense if I did it all at the same spot. Let me do this. I get a sticky note. Write out what's happening. So x plus 2, x plus 3. We could think of it like this. First distribute the x, then distribute the 2. So I'm doing x times x and x times 3. That's what we just did here. And then I'm distributing the 2, which is 2 times x and 2 times 3. Is this easier to understand? Because as I wrote this, this makes more sense to me. Like first I distribute my first term, then I distribute my second term. But it's the same FOIL method because I'm doing my first terms and then my outer terms, then my inner terms, and then my last term. Well, I'm going to put it up there for you in case it helps. But we did our first terms, our outer terms. Now we'll do our inner terms, which is what 2 things do we multiply?
2 and x.
2 and x, perfect. So 2 times x, which gives us what?
2x.
2x. And last but not least, our last terms, which is which 2 items?
x3.
X and 3.
2 and 3.
2 and 3.
Oh, the last one's on top.
Yes, the last one's on
the
each.
end. You're right.
Yes.
Okay, yeah.
So 2 and 3. So I'm doing 2 times 3. Which is what?
6.
6. And you might start to notice a pattern. When we multiply, these are called binomials. You don't need to know that, but it gives me a word to call them. Binomials just means that they have 2 terms. Bi means 2. Nomials, a fancy word for number or term. So 2 terms. So we're multiplying binomials. That's what's happening. And you'll notice that when we start with 2 binomials that are just x plus something, we're always going to come up with an answer that is x squared plus x plus a number, just like we did here. X squared plus x plus a number. It's always going to go in descending order from the biggest x to the smallest x to the no x. Okay, so we've done our FOIL method. We have x squared plus 3x plus 2x plus 6. We have one last step to take before we're done.
Combine like terms.
Combine like terms. What are my like terms?
3x and 2x.
3x and 2x. So when I add them together, what do I get?
5x.
5x. And then we just bring everything down. We have x squared plus 5x plus 6. That is our answer.
And that is confusing.
It is confusing. It is a very confusing process compared to what we've been doing. So don't feel bad that it feels a little confusing. I never expect any of you to get something the first time I show it to you. Because this is a lot, to be honest. There's a lot of moving parts. And this is probably the most difficult thing we've attempted to do so far. So don't feel bad if it feels confusing, because it is a little confusing. Okay. It is 10:22. I wanted to at least introduce this to you today. We're going to take a little break, and after our break, we'll do a little more with this. And I'll let you know how involved with that we're going to get once we get back. But let's say it's 10:23. We'll start back up around 10:40-ish, maybe 45. Okay. All right. I'll put a little note on my computer, and I'll pause the video, and we will be back. Right. We're back from break. Let's do a little more practice with this FOIL method together. I'm going to show you another problem, and draw a line under this one from before break. Okay. So this will be the last example on this page. Here we go. Let's try x plus 4 times x plus 3. So we're using the FOIL method. First, outer, inner, last. So I'm just going to write that out to the side. F O I. Okay. Let's start with our first terms. What are the first terms of both of these parenthesis sets?
X.
X and X. Good. So I'm doing x times x first, which gives me what?
X.
X times x gives me x what?
To the second
Squared. X to the second power. Beautiful. Beautiful. So there's our first term. Now let's do our outer terms. We're just finishing the distribution of the x here. So I'm doing x times what?
3.
3. So x times 3 gives us what?
3.
3x. Good. Now I will switch colors. And what I'm going to show here with this work, we're still using the FOIL method, but I'm also trying to show with colors that first we're distributing the x, and now we're distributing the 4. What are my inner terms?
4 and X.
4 and x. Good. And 4 times x gives me what? 4x. And now our last terms.
Times 3.
4 times 3. Good. And what is 4 times 3? 12. Good. So we did our first terms, our outer terms, our inner terms, and our last terms. We have now distributed everything. We've multiplied it all out, and we are here. I have x squared plus 3x plus 4x plus 12. Now I need to combine my like terms.
3x and 4x.
Yes, 3x and 4x. Those go together. What is 3x plus 4x?
7x.
7x. Good. And then we'll bring the rest down. I have x squared plus 7x plus 12. That is our answer. There we go. So if we wanted to give a little step-by-step guide, we could say step 1, here written in red, is distribute the first term. So that was our x times x and our x times 3. So our first and our outer. Yes. Oops. Thank you. Thank you. I appreciate you saying something. So distributing the first term, that's the first half of FOIL. F-O. First outer. And the next step is that we distributed that second term, the 4. And that's the inner and the last. I-L. And last but not least, we combined our like terms or our middle terms. If we're following the FOIL method, the ones that we add together will always be the 2 terms in the middle.
Always.
As long as you follow the FOIL method,
Okay.
yes, always.
Okay.
Now, if we do other methods, it could change, but with this method, they should always end up being in the middle.
Okay.
Okay, well, let's see. Step 3 was combine. It should be the middle terms. There's some steps. I'll give everybody a minute to copy that down if you find those steps helpful. Move this page. If you're still writing, don't worry. I'm gonna keep it up here. Just put it right in the corner. I start I'm gonna title a second page of notes while I keep this up. I'm just writing page 2 and day 26 notes continued. Okay. Can I move this? Does anyone still need it?
Okay.
Happy to keep it up if anyone is still writing. Okay, just yell at me if you need to see it again. So let's do one last one together, maybe. See how we feel after that. And then I'd like for you guys to try some of these on your own, unless, of course, we all would like more practice as a group. So I'm actually going to title this More Practice with the FOIL Method. Just with FOIL method. This time I'm going to give you x plus 5 times x plus 6. So, using the FOIL method, what is my first step? X times x, good. So we're going to distribute this x times x, which gives us what? X squared, good. Okay, what do I do next?
That's gonna be the outer.
The outer terms, which is x and 6, good. So now I'm doing x times 6, which gives us what?
6x.
6x. 6x.
Yeah.
Yes.
So, yeah.
So remember, whenever we're not worried about, we're not multiplying variables necessarily, we're just doing x times the coefficient 6. So it just places that 6 in front of the x to show us that we have 6 of these x's. So 6x. All right, we have distributed our first term. We have done the first and the outer. Now we need to distribute the second term and do inner and last. So what's my next step?
5 and x.
Yes, we'll do 5 times x, which is what? 5x, good. And what's our last step? 5 times 6, my last terms. So 5 times 6, what does that give us?
30.
30. Good. Good, good, good. So if we're following these steps, put this right here. Done step 1, we distributed our first term. We did the first and the outer. We did the second step, we distributed the second term, the inner and the last. What should we do next?
Combine.
Combine like terms. What are my like terms?
6 and 5x.
6x and 5x. And what is 6x plus 5x?
11x.
11x. Good. Technically, I don't have a fourth step written, but there is a fourth step. What needs to happen now?
Bring everything down. Bring everything.
Bring everything down. So I might write that on here. Or bring everything down. We bring down x squared plus 11x plus 30. And that is our answer. That, and here it is. Okay. Is it starting to make a little more sense after seeing it repeated a few times?
Yes.
Good, good. Okay, so do you think you guys can try one on your own? I'm gonna see, I'm gonna give you one. And I want you guys to try. I'll give you two in case somebody finishes early. I'm gonna give you two problems. I want you to try to at least finish one by yourself. Let's see. Squish it too much. I can fit another one. Let's do. For you to try. And if you finish that one, let's give you this one. This will be the challenge. X plus 2, x minus 3. Let's see if anyone can figure out how to do this next one, but just focus on the x plus 3 and x plus 7 first. I will set a little timer for us. I'm going to give you 5 minutes. Do not feel pressured to finish both in these 5 minutes. Just get as far as you can. So I'll pause this. If you're practicing at home, pause the video now, and we'll be right back. All right, so first problem, we have x plus 3 times x plus 7. Zoom in on that a little bit. So, what are some answers that you guys came up with? Somebody wants to share.
X squared plus
Okay.
10x plus 21.
X squared plus 10x plus 21. Did anybody get something different that wants to share? Or did every single person in this room get this answer? X squared plus 10x plus 21.
Yeah, but I didn't get that. But I ain't gonna tell you what I got. Let me go back and look at it.
Well, let's see. Did everybody get x squared as your first term?
Yeah, I got that.
Give me some numbers for the second term everyone got.
10x.
10x.
And it.
You got 10x. Did anyone get something other than 10x?
I got a question.
Yes.
Well, I got would it be wrong if I put the 10x first?
Like 10x plus x squared
Yeah.
plus 21?
Does it matter? Or?
Technically, that is not incorrect. That is still all three terms if you have them written side by side. In the future, as we go up to higher levels of math, it's good to get in the habit of putting the term with the highest exponent at the beginning.
Okay.
So it would be a good habit to get into, but for today, I would not count that wrong. You got the right numbers, so that's good. Okay, so everybody got 10 in the middle, 10x?
Yeah.
What are some numbers we got for our last term? 21 is what I have written.
Why didn't time?
You didn't times. Did you get plus 10?
Yeah.
Okay, so plus 10. Anybody get something different than 21 or 10? Everyone got one of these two? Okay, so let's check. Let's see what the correct answer is. So, what's my first step?
X and X.
X and X, which gives me X times X is what?
X2.
X2, X squared, X to the second power. Yes.
That.
Yes. Okay, so we have X times X is X squared. What's next?
X times 7.
X times 7, which is what?
7.
Good. 7X. So let's move to the next two. What do I do next?
Times X.
3 times X, which is
3.
3X. And last but not least,
3 times 7.
3 times 7, which is
21.
21. Good. So 21 is the correct ending term. X squared is the correct beginning term. What is there left to do?
Combine.
Combine. I'm going to combine my two terms in the middle here. 7x plus 3x. 10x. So this is our answer. X squared plus 10x plus 21. That is correct. Now, after going through this, if you did not get this originally, I hope that this clears things up and you understand how this is the correct answer, why it's the correct answer. If at any point you don't understand one of these things, please let me know and we can talk about it. I won't be frustrated. This is brand new. Okay. So just communicate with me. I can't help you if I don't know you need help. All right. Any questions on this first problem? Okay.
Second one, yes.
Second one is tricky.
I got about halfway.
Okay. So let me hear, first of all, who attempted the second problem? Okay, a few of us did. Cool. Does anyone want to share some of the answers they got so we can compare?
Like x squared minus 1x minus 6.
So x squared minus 1x minus 6. Anything different? Anyone get something different?
I didn't get an end answer, but I tried to divide
Okay.
instead of multiply.
Oh, okay.
First.
Gotcha.
Gave me like a really long decimal, and I'm like, okay,
Yes.
it's probably not bad.
Okay, so were you thinking since we had a minus, like subtraction will divide instead?
Yeah,
That's a really good thought. That's a really good thought. We actually don't have to do that. It's not going to be as complicated as it might sound. But that's a really good guess. Did anyone finish this problem and get a different answer than I have written?
I got all those same numbers. I just put a plus sign in between my x squared and my x.
Okay, so x squared plus
I just put x.
x.
Yeah.
Still minus 6?
Yeah.
Okay. So 2 different answers now. Any other answers?
0, 0, 0.
0, 0, 0. Oh, Jimmy. Well, we're gonna see. Let's work it out, and I'll put this to the side for a minute.
The minus threw me off.
Yes, the minus can be shocking after we've been working with pluses. But let's break it down the same way we did the last one. And I'll show you it's not as scary as you might think. So what's our first step? Do the x's together. Our first terms, x times x is what?
X squared.
X squared. Okay, what comes next?
X and -3.
Okay, so here's where the change happens. Since I have x times 3, but there's a minus right here, we're going to treat this as if it were -3. Okay, so really we're doing exactly what you said, x times -3. So, yes, we'll get negative 3x, and we'll write minus 3x. So all we did first is take x times x and then x times 3. Since there's a minus in the middle, we bring it down. It's a lot like that.
So then is it?
Go ahead. What's the next part?
2x.
Yeah. Distributing
Plus
2.
2x.
Good. And this is positive. Plus 2x.
2 and 3, which is negative 6.
Good. Now 2 times negative 3, which is negative 6. Okay. So we are here. Does everyone see how we got to this point? We just did x times x to get x squared, x times 3, or x times negative 3, negative 3x. Then we did 2 times x to get 2x, 2 times negative 3 to get negative 6. What do I need to do next?
Combine negative 3x plus 2x, which is negative.
Now we combine our like terms, and here I have negative 3x, and I have positive 2x. Negative 3 plus 2,
Negative.
negative 1. So I'm left with negative 1x, or we can just write x. So I have minus x in the middle, negative x.
Bring everything down.
Bring everything down. So I'll get x squared minus x minus 6. Be our answer. So the only thing that's different here is we have to remember our negative multiplication rules. And in case we forgot, it's never a bad idea to review those. I'll make a little sticky note. You're welcome to do the same if this is helpful. But just remember, whenever I am multiplying, so I'm gonna write negative. Multiplication rules. I take a positive number times a positive number, I get what kind of answer? A positive answer. If I do, let's see, a negative number times a negative number, this one's a trick question. Don't think too hard about it. What kind of answer do I get? A positive again. So the only two ways that we can get a positive answer is if we have two positives or two negatives. Same signs give us a positive answer. Two positives or two negatives. Same. Okay. And the only options that will give us negative answers are when we have numbers being multiplied with different signs, such as a positive and a negative, or a negative and a positive. So our little note about positives and negatives. If it's helpful, great. You might already have that rule memorized by now, but if not, feel free to write it down. I'm gonna look at some more with negative numbers. A little more. Can I move this? Is anybody copying it down? Looks like we're all ready. Okay. What if I gave you x minus 3 times x minus 2? Now we have two negatives. Take a look at what that's going to do to our answer. So using the FOIL method, we're still going to do the same steps. We're going to start with our first terms, which are x and what? X and x, which give us x squared. Next we do our outer terms, which is what? X and 2. Now what do I need to keep in mind about this 2? It's negative because there's a minus. We always look at the sign that is directly to the left of the number. So minus 2 means it's a negative 2. X times negative 2 gives us what?
Negative 2x.
Negative 2x. What about? Let's see when the video is over. Okay, so we have minus 2x. Now, what do we do next? My inner terms, which is which 2?
Negative 3x.
Yes, good. Good job recognizing that because it's minus 3, this is also negative 3. So negative 3 times x gives us negative 3x or minus 3x. And last but not least, yes, my last terms.
Negative 3, negative 2.
Negative 3 times negative 2, which gives us what?
Positive 6.
Positive 6. Good. This is where those multiplication rules really come into play. Because if we don't remember that a negative times a negative gives us a positive, we will not have the correct answer. And that'll give us problems in the future. We need to be really careful at each step and notice whether we are looking at positive numbers or negative numbers. So now I have x squared minus 2x minus 3x plus 6. What should I do from here?
Combine the minus 2x and the minus 3x.
Good. Combine our like terms, our minus 2x minus 3x.
Negative 5x.
Negative 5x. Good. It's basically like negative 2 minus 3. Or negative 2 plus negative 3. Really what's happening. Negative 5x. And then we bring everything down like we've been doing. X squared minus 5x plus 6. And that would be our answer. Crazy stuff. You guys are doing really good with it though. Okay, what if I threw some numbers in? Like this. Did 2x plus 3 times 2x minus 3.
2x times 2x.
Perfect. 2x times 2x.
4x.
And that gives us 2 times 2 is 4. X times x is
X.
X squared.
x squared. Good. So we'll get 4x squared. So same as all the others, we're still getting x squared as our first term. We have a 4 in front of it now because there were numbers involved. But that first term, as long as we start with an x and an x, should always come out to be x squared. So what's next? Outer terms.
2x. 3.
2x and 3. Now, what kind of 3 is it? Negative 3. That's the only part we got to be careful about. We've got a minus sign, so it's negative 3. So what is 2x times negative 3?
Negative 6.
Yes, negative 6x. Beautiful. Okay. What comes next?
Yeah.
My inner terms. 3 times 2x.
6.
6x. Good. That's positive this time. And last but not least,
3 times 3, negative 3 is
Good.
negative 9.
3 times negative 3, which gives us negative 9 minus 9. Good. Now this one's interesting because something
cancel out.
special happens. They cancel out. Yes. We have minus 6x and plus 6x. They cancel each other out. What happens whenever a term cancels out? Do we write anything?
That becomes x.
It just, ooh, does it become x?
No.
No, it becomes 1.
It becomes
Nothing.
Nothing.
nothing. It disappears. It disappears. And here's why. If I have negative 6x and positive 6x, here's how I can think of it. Let me grab some little counters. I have some counters. Okay. Let's pretend this is an x. This is positive x. 1, 2, 3, 4, 5. We need one more. 6. Okay. So positive 6x right here. And I am going to subtract 6x, which is the same thing as adding that negative 6x. Now, every time that I add a negative x or take an x away, I'm going to flip one of these over. If I flip them all over, they have disappeared. So there's 1x. There is, my goodness, 2 x's, 3 x's, 4 x's, 5 x's, and 6 x's. When the squares are red, they don't exist. So these cancel out. They're going to be gone. It'll be just 0. It would be 1x if we had negative 5x and 6x, because we would subtract 5 and be left with 1. But as you can see, these are all red. They're gone. There are no x's left at all. So what's really happening here is I have 6 minus 6, which is 0, right? If I have 0x, that means I have no x's. There's no point in writing 0x. These cancel out. So what would our answer be with no middle term?
4x squared minus 9.
Good. We're still going to bring it down like we normally would. 4x squared minus 9. our middle term disappears. Gone. And this is another pattern that you may come to recognize later on, way down the road. Whenever we have two binomials that have the same numbers but opposite signs, where we have 2x plus 3, 2x minus 3, that middle term is always going to cancel out like that. We'll have no middle term, which is kind of cool to think about. But so there's a fun example. Okay, it is 11:35. We've got about 20 more minutes in here. I want you guys to have lots of time to do an exit ticket today. And I have not given lots of time in the last few days, I feel like. So I'm going to go ahead and give you all an exit ticket. If you complete it, you are free to go. While you're working on that, though, please feel free to ask questions. If you would like any help one-on-one, just holler at me. I'm happy to come around and do that. But before that, do we have any questions about anything that we did today? Anything at all? Make a ticket for you. You're welcome to wait for it if you want. I will make copies, but you can also write it on your own, and that is fine with me. Oh, this will be the last exit ticket of term 3 ever. This is it.
Hey, what about tomorrow?
Tomorrow's Thursday,
Wait,
and
it is?
I've been trying to keep that promise. No exit ticket on Thursdays. This is your last exit ticket of term 3 because next week is finals week and tomorrow's Thursday. So crazy.
I thought tomorrow was Wednesday.
That's what I thought. I spent all morning thinking it was Tuesday today. Algebra 1. Pretty wild. This is our day 26 exit ticket. This is, as always, due on Friday. And remember, you may make corrections up until Friday as well. February 20th. Okay. So, your instructions. Using the FOIL method, multiply the expressions below. We'll lose points if you do not combine your like terms. Make sure you combine like terms at the end. So, here is your first one. Two times x plus 7 and your second one. Plus 5. Okay, it'll just be these two today. And you want a copy, just let me know. I'm going to make those now, but that is it. I'm gonna end that video there. That is all.